people will start showing up here about 5 minutes in.
Yeah, I noticed actually I missed the last 2 days, so this was the first day I'm joining. I'm like, it's been busy.
Yeah, it tends to go in cycles. Yeah, here's a couple folks. All right. So we are going to pick up on the second half. First half yesterday, we did a recording of it if you want to look through it, but it's more Econ 101. And currency translations, which is an interesting piece. You want to look at that. But we are now going to pick up with some stuff that's a little more useful. Forecasting methodologies and techniques. So we don't do a lot of forecasting at PACCAR. We don't like to do it because our supply base tends to want to take that as a order when we give them a forecast. And then when it drops, they want us to pay them. So our kind of response is, well, we're just not going to forecast. What we will do is we'll show you the EDI backlog of orders. So we have, I think it's out 30 days is locked in. We're good for those orders to the supply base. And that's the 830 EDI, I think. The 862 shows 30 days and beyond what's in the system, usually like up to 6 months. But that's just partial orders. I mean, when we're booked up like we are now, then it's pretty good data. But when we're at the bottom of a recession, there's like 2 weeks or 3 weeks of orders out there and then nothing. So that's what we use for a forecast. But I have done, when I did tires, I did more forecasting because I had to kind of make some trade-off decisions. So I'll show you some of that. Short-term versus long-term, if you're trying to forecast stuff over more than even 6 months, it's a guess. I mean, you're going to have to make so many assumptions there that you'll be lucky to be even close a year from now. Usually when I'm forecasting, I try to stick to less than 6 months. Macro versus micro, it's much easier to forecast the big stuff than it is the little stuff within industries. That usually catches you by surprise. And then the Delphi method, you'll see questions on this. So what the Delphi method is a bunch of smart PhD guys got together and said, what if we don't have data? Then how do we do a forecast without data? Well, what we'll do is we will get a bunch of experts together and we'll separate them all so they can't talk to each other. And we'll give them all the same series of questions. And then we'll get a forecast from that. So that's the Delphi method. It's a little hokey, but when you got nothing, it's something. And then there's correlation and regression analysis. You had most of you had this in school. Basically regression, multiple and simple. So what it measures is the statistical but not causal relationship. So what's the correlation between the two variables? Not what the dependent variable does not necessarily cause the independent variable to move one way or the other. It's just a correlation. They move together or they don't. So R squared is the percentage of variance that is accounted for by the model. We'll cover that in a little more depth. Time series. So this is forecasting. All forecasting is time series. Measures factors that influence changes in data over time, such as trends, cycles, seasonal fluctuations, etc. And the central tendency is the mean. Remember the mean, median, mode from your statistics class. Mean is the average. Median is the most common score. Median is the exact middle, and mode is the most common. All right, variability, measures of dispersion, standard deviation. Measures of variability include things like range, variance, and standard deviation. And analysis of cyclical data. A cycle is tied to economic fluctuations. Remember, we studied this in C1. Peak, trough, peak, trough, peak, trough, and then here's your growth trend. Economic indicators are generally used to predict the business cycle with some success, not a great deal. Seasonality will also cause cyclical data. So there's a little bit of seasonality to our trucking business. The first and fourth quarters tend to be stronger than the second and third quarters. Moving averages tend to dampen cyclical data, so trends are easier to spot. We'll cover how to get to a moving average. Most of you already know. But that's just all it's used to flatten it out so you can kind of see the trend easier. Trend analysis, an increasing or decreasing pattern of demand over time. Change in this series of data over time. Winter's model, which we'll cover in a minute, or seasonal exponential smoothing may help to discern the trend. So all you need to remember about Winter's model is it's exponential smoothing, basically, fancy exponential smoothing. Then the decision tree analysis, you guys have all seen this. This is a decision tree. Making tools that maps alternative courses of action. And then Box-Jenkins. I cover this in the advanced forecasting, but you need some software and some other things to do this. I've never really used it for any forecasting at PACCAR. It is kind of cool, but the only thing that you need to remember is it's named after the statisticians George Box and Gwendolyn Jenkins. And it's got this ARIMA model, which is the autoregressive integrated moving average. Just remember that Box-Jenkins goes with ARIMA. That's all you need to know for the test. And then Winters is exponential smoothing. And then we'll cover exponential smoothing in a little more detail. Little data is needed. You can use the Delphi method to estimate the initial forecast and then use exponential smoothing to get hopefully a better forecast. Then the demand for the most recent period and the estimated forecast periods are used to calculate the forecast. It's basically weighting. And then there's everybody's favorite, the Monte Carlo method. Used if you just don't know what direction things are headed. It's a bunch of simulations, again, using computer software. It provides a range of possibilities and outcomes and the probability that each will occur. So this is a Monte Carlo analysis output. And this is your Monte Carlo. So some techniques. Simple moving average, sum the numbers, divide by n. So if you want a 3-month moving average, you sum 3 months of data and then divide by 3. The weighted moving average, often chosen to give more weight to the more recent data, less weight to the older data. So simple weighting in November data, 35%, December data, 65% for a January forecast. And then exponential smoothing. So the simple moving average, the past observations are weighted equally. And exponential smoothing assigns exponentially decreasing weights over time. So you got exponential smoothing, you got alpha, beta, and gamma. Alpha, we'll cover this in some detail, but alpha in the formula, they're closer to 0. More weight is given to the observations from the more distance past. So if your alpha number is 1, you're giving all the weight to the recent data. If it's 0, you're giving all the weight to the more distant data. Winter's model. So I did actually use this for tire forecasting when I was doing tires. It's a seasonal method that comprises a forecast equation and 3 smoothing equivalents. It looks like this. So basically, this is the data in blue is the data that I had from Bex, I think. So this is for Michelin. And the number of tires. And the red data is what the Winters model gave me for a forecast over the up. So this was done in early January 2017. And here's the data that it's forecasting. And then you can also do the same thing with share. But it worked pretty well. And once you get the spreadsheet set up, you just add to update with the latest data and copy down. I cover that in advanced forecasting too, which I'll make a recording of, but it's way more information than you will ever need to know for the ISM test. And then Box-Jenkins is trying to remember the name of the program here. Hang on. I'll tell you. Starts with a Q. Peak. What's the name of that statistics program that we have? I know it's on here somewhere. Anyway, you need a statistics program to run the Box-Jenkins stuff. And we have one you can get access to if you want it and want to do it. And I got a video that kind of walks you through it, but it's like PhD complicated. And then there's least squares regression. Assumes that the dependent variable being calculated is in a linear relationship with the independent variables that are known. Regression does not imply cause and effect. You got to remember that, only correlation. So here is some stuff. If you want to practice some stuff on Excel and regression, there's regression 2 and there's regression 1 here. And we got some more regression examples you can work through to your heart's content. Forecasting techniques, cost regression analysis, otherwise known as CRA, is what we would call a should price. Identifying opportunities and commodities. It's very closely related to linear performance pricing that you learn in MCE. They're both based on regression, so it's pretty much the same thing. And here's a spreadsheet. If you want to do more analysis on regression, you got the graph, you got answers in the forecast. Shows you how to do it in Excel. It's an older version of Excel, but you could figure out how to adapt it. And then if you're really into regression, you can read this white paper, which is like 50 pages on regression for cost analytics. I have not even made it through a few pages of that, but you never know. You might run into somebody that wants to read that stuff. All right. What is most likely to cause a long-term change in a forecast for copper? So we use copper in our harnesses. What would cause a long-term forecast? Thinking not labor availability.
Is it A alpha?
I would, that's what I would go with, but could be interest rates too. Let's see. B it is. What's an indicator? Industrial production.
I think that's a different question.
Oh, it is a different question, isn't it? That's the one we had yesterday. No, it's interest rates. All right, because interest rate increases are likely to affect building starts, automobile purchases, and so on, thus reducing the need for copper. Yeah, well, so are those are housing starts, but I guess interest rates is the better answer. They're just less likely to try the long-term change. All right. There is a case study if you want to work through that. The answers are here below the questions. So I'll let you take a look at that if you want. We got 6 questions to do. So I want you guys to go ahead and get started on them, and then raise your hand when you get done. Otherwise, we'll go over answers at 2:25. Oops, wrong thing. Numbers 6 through 11. All right, let's go over some answers here real quick. Number 6 is Bravo. Remember, R squared is what you're looking for when you want proportion of variance. 7 is also Bravo. Qualitative methods are non-numeric by definition and use the opinions of people considered knowledgeable. There's quantitative. 8 is alpha. R squared again indicates the proportion of variance dependent variable is accounted for by the independent variables. 9 is delta. Surface finish because it has the highest number. 10 is Charlie. Regression analysis describes the relationship between two variables. And 11 is also Charlie. Delphi technique is a qualitative method that involves gathering opinions. All right, any questions? Tomorrow we will pick up with, what are we doing tomorrow? Forecasting for sourcing strategies, more basic forecasting techniques. Talk to you guys later.
Thanks, Rick.
Yep.